Hey there, builders and makers. Have you ever imagined creating anything you can dream up right in your own home? That's the promise of 3D printing, and it's changing the way we design, build, and even think about manufacturing. Imagine holding a physical object in your hand, moments after you finish designing it on your computer. This isn't science fiction, it's the incredible reality of 3D printing. This technology is revolutionizing industries from healthcare to aerospace, and it's even empowering everyday people to become creators. Just like the internet and computers before it, 3D printing is a game changer. It's democratizing manufacturing, making it possible for anyone with an idea to bring it to life. Get ready to dive into the exciting world of 3D printing and discover how it's shaping the future. So, how does this futuristic technology actually work? The magic of 3D printing lies in its ability to build objects layer by layer from the bottom up. Think of it like digital sculpting, but instead of clay, we're using plastics, metals, and even chocolate. It all starts with a digital design created using computer-aided design software. This design is like a blueprint that tells the 3D printer exactly what to build. Once the design is complete, it's time to slice it up. Slicing software divides the 3D model into hundreds or even thousands of thin, horizontal layers. These layers are like the individual slices of bread in a loaf. Finally, the 3D printer gets to work, following the instructions from the sliced design. The printer deposits or fuses material layer by layer, gradually building the object from the bottom up. It's like watching a sculpture emerge from a pool of liquid, except in this case, the pool is made of molten plastic or metal powder. Now let's dive into the fascinating world of 3D printing and explore the different types of 3D printers out there. Just like there are different tools for different jobs, there are various 3D printing technologies, each with its own unique strengths and weaknesses, tailored for specific applications. One of the most common and widely used types is fused deposition modeling, or FDM. FDM printers work by extruding a thin filament of melted plastic, much like a hot glue gun, onto a build platform. This method is popular for its simplicity and cost-effectiveness. The plastic hardens quickly, and the printer deposits layer upon layer until the object is complete. This makes FDM ideal for creating prototypes and everyday objects. Another popular method is stereolithography, or SLA. SLA printers use a UV laser to selectively cure a liquid photopolymer resin, hardening it into the desired shape. This technology is known for its precision and ability to create intricate details. This process creates highly detailed and smooth surfaces, making it ideal for prototypes, intricate models, and even jewelry. Selective laser sintering, or SLS, is another powerful technology that uses a laser to fuse powdered materials like nylon or metal together. SLS is known for its ability to create strong and durable parts with complex geometries, making it perfect for functional prototypes and end-use parts. For truly high-end applications, there's direct metal laser sintering, or DMLS. DMLS printers use a high-powered laser to melt and fuse metal powder layer by layer, creating fully functional metal parts with incredible precision and strength. This technology is often used in aerospace and medical industries. New 3D printing technologies are emerging all the time, pushing the boundaries of what's possible and opening up new possibilities. We're seeing printers that can print with multiple materials at once, allowing for more complex and functional designs. Bioprinters that can create living tissues, potentially revolutionizing the field of medicine and organ transplantation. And even printers that can build houses, paving the way for innovative construction techniques and affordable housing solutions. The applications of 3D printing are practically limitless, spanning across industries and touching every aspect of our lives. From the smallest custom parts to large-scale industrial components, the versatility of 3D printing is truly remarkable. Let's take a look at some real-world examples where 3D printing is making a real difference. These examples highlight the transformative power of this technology in various fields. Prototyping is one of the most common uses for 3D printing. It allows for rapid iteration and innovation, enabling designers to bring their concepts to life quickly and efficiently. Designers and engineers can quickly create physical prototypes of their ideas, allowing them to test and refine their designs before going into mass production. This process significantly reduces the time and cost associated with traditional prototyping methods, In the world of manufacturing, 3D printing is used to create everything from custom tooling and jigs to end-use parts for airplanes and automobiles. This technology is revolutionizing the way we produce complex components. For example, GE Aviation uses 3D printing to manufacture fuel nozzles for its jet engines, resulting in lighter, more efficient engines. This not only improves performance but also reduces fuel consumption and emissions. Healthcare is another field that's being transformed by 3D printing. The ability to create patient-specific models and devices is enhancing the precision and effectiveness of medical treatments. Surgeons can use 3D printed models of patients' organs to plan complex surgeries, improving outcomes and reducing risks. These models provide a tangible reference that can be invaluable during intricate procedures, while researchers are developing 3D printed tissues and organs for transplantation. This groundbreaking work holds the promise of addressing the shortage of donor organs in the future. 3D printed prosthetics are becoming increasingly common, offering affordable and customizable solutions for amputees. These prosthetics can be tailored to the specific needs and preferences of each individual, enhancing their quality of life. Even the world of education is embracing 3D printing. This technology is being integrated into curriculums to inspire creativity and innovation among students. Students can design and print their own creations, bringing their ideas to life and learning valuable STEM skills in the process. This hands-on experience is invaluable in preparing them for future careers in technology and engineering. From designing and printing their own toys to creating models for science projects, 3D printing is empowering the next generation of innovators. This technology is fostering a new wave of creativity and problem-solving skills among young learners. Section 5. The Power of 3D printing faster, cheaper, and more creative. So, why is everyone so excited about 3D printing? Well, it offers a whole host of advantages over traditional manufacturing methods, making it a game-changer for businesses and individuals alike. One of the biggest advantages is design flexibility. With 3D printing, you're not limited by the constraints of traditional manufacturing processes. You can create complex geometries and intricate designs that would be impossible to make using traditional methods. Another major benefit is reduced lead time. 3D printing eliminates the need for expensive tooling and lengthy production runs. You can go from design to finished product in a matter of hours or days rather than weeks or months. 3D printing can also be more cost-effective, especially for small batch production or highly customized products. Since you're only using the material you need, there's less waste and lower overall costs. Customization is another key advantage. With 3D printing, you can easily create one-off products or personalized designs to meet specific needs. This is especially beneficial in fields like healthcare, where customized prosthetics and implants can significantly improve patients' lives. Section 6. The Challenges of a 3D World. While the future of 3D printing is incredibly bright, it's important to acknowledge the challenges that come with this disruptive technology. These challenges are multifaceted and require a comprehensive approach to overcome. Like any tool, 3D printing has its limitations, and we need to address these challenges to fully realize its potential. This means understanding both the technical and practical constraints that currently exist. One concern is intellectual property theft. The ease with which designs can be copied and reproduced poses a significant risk. With 3D printing, it's relatively easy to copy and reproduce designs, which raises concerns about counterfeiting and intellectual property protection. Companies must develop robust strategies to safeguard their innovations. Another challenge is the skill gap. The rapid advancement of 3D printing technology means that the demand for skilled workers is outpacing supply. As 3D printing becomes more prevalent, there's a growing demand for skilled workers who can design, operate, and maintain 3D printing equipment. This requires a concerted effort in education and training. We need to invest in education and training programs to ensure that we have a workforce that's equipped to handle this new technology. This includes both formal education and hands-on training opportunities. Material limitations are another factor to consider. The range of materials that can be used in 3D printing is expanding, but there are still significant constraints. While 3D printing materials are constantly evolving, there are still limitations in terms of the types of materials that can be used and the properties of the finished products. This affects the durability and functionality of printed items. Finally, we need to address the environmental impact of 3D printing. The sustainability of this technology is a growing concern. Some 3D printing processes can generate waste materials, and the energy consumption of 3D printers can be significant. This necessitates a focus on eco-friendly practices. We need to develop more sustainable 3D printing technologies and practices to minimize our environmental footprint. This includes reducing waste, improving energy efficiency, and using recyclable materials. Section 7: 3D Printing Shaping the Future. Despite these challenges, the future of 3D printing is incredibly exciting. As the technology continues to evolve and mature, we can expect to see even more innovative applications emerge, transforming industries and improving our lives in countless ways. Imagine a world where we can 3D print personalized medicine tailored to our individual DNA, or build sustainable homes and buildings on demand using locally sourced materials. The possibilities are truly endless. 3D printing is empowering a new generation of creators, makers, and innovators. It's giving us the tools to turn our imagination into reality, to solve complex problems, and to build a better future. The 3D printing revolution is here, and it's only just beginning. So buckle up, get ready to embrace the future, and let's start building. Section 8. The future is in your hands. As we've explored the incredible world of 3D printing, it's clear that this technology has the potential to revolutionize the way we live, work, and create. But the future of 3D printing isn't just about the technology itself, it's about how we choose to use it. It's up to us to harness the power of 3D printing for good, to solve problems, to empower communities, and to create a more sustainable and equitable future for all. So let's embrace the possibilities, address the challenges head-on, and work together to shape the future of 3D printing. What will you create?